Hi, I'm Tim Zacharias with Cougar USA and your host of Building Value. Today, I'm joined by Mike Fehr with Fehr Solutions. Mike, welcome to the show.
Thanks, Tim. I'm really enjoying being here.
All right. On this episode, we're going to cover Fehr Solutions and how they help their clients manage water quality. Also going to look at some applications in commercial buildings for water treatment and filtration, as well as cover some water quality issues specifically around the COVID-19 pandemic and how to address them with a plan to reopen a building.
On Building Value, we go behind the scenes at some of the most iconic buildings in Texas to showcase the incredible people that design, build, and maintain them and their impact on the community.
All right. So can you tell me a little bit about kind of where you grew up and what you did after high school?
Sure. No, I grew up in Nebraska, which is why I'm a football fan and not a baseball fan, although the baseball program is good. Grew up in Omaha, Nebraska. Ended up going to University of Nebraska, getting a chemistry degree. Left Nebraska and went to Missouri and lived in St. Louis for a while. That's where I started in the water business. So I started there in 1988, selling water treatment chemicals. After about a year of that, I found out that I wasn't very good at it. I really did not have a passion to sell chemistry, but I really missed chemistry itself. So I went back and got a master's at St. Louis University and followed that up with a PhD at Iowa State University. So kind of kept in the Midwest.
Yeah.
And that final PhD was in physical chemistry and actually a lot of virus work. Not quite the same viruses that we're working with right now.
Sure.
But did a lot of work on those things, and that was very interesting. And then went from there to Naperville and worked for a company called Nalco in research and development for about 6 years. And then in 2003, my wife and I formed Fehr Solutions to work with clients that needed assistance but didn't want to buy chemistry.
Gotcha. So that was the what made you make the jump was kind of switching to more of like a solutions provider, I guess, hence the name.
Right.
Fehr
And
Solutions.
so I had worked in R&D and had really enjoyed that. Nalco at that time was going from a privately held company to a publicly held company to a privately held company. They started to not be as focused on R&D as they used to be. And also, having been in it for 6 years, I'd kind of realized that not that there weren't more developments that could be had, but the cost-effective ones were really kind of gone. We were really using technology still from the 70s, kind of repackaging it a little bit, tweaking it a little bit. But it seemed to me that there was a better way to do water treatment versus just purchasing it in a drum and selling it. So we started to work with our with clients then to figure out how to do things better. And that's what we've been doing ever since.
Nice. And so what would you say, like you would offer a typical client, and who are the people that you would typically work with?
Sure. So we typically work with, not always with larger water users, but those tend to be the people that we work with quite a bit. So we work with food companies, pharmaceutical companies, energy companies, people that have, utility water, which would be boilers, cooling towers, food processing, some wastewater stuff, reclaimed water, laboratory DI water. And really what we do is we act, at least we try to act in the customer's best interest. We don't have any interest in selling chemistry. We don't have any interest in selling equipment. What we're trying to do really is asset protection. So we're trying to make sure that the assets they've purchased are being protected on a long-term scale. And we're trying to do that as cost efficiently and safely as possible. So we're looking for technologies that are, maybe a little bit out of the mainstream, but have a good scientific backing behind them. So those are technologies where, we can reduce water usage, for example. And we know that if we can reduce water usage, that chemistry usage follows. So we don't use nearly as much chemistry. So those two things go hand in hand. And the same with energy. So we can also decrease energy usage at the same time. And we're doing all that while we're following performance metrics. So a performance metric is something that either we've defined or an outside group has defined, that is something that you should follow and try to meet to hit a metric, right? So for example, if you're trying to prevent corrosion in the system, right, there are corrosion rate metrics that we can follow. So we measure corrosion rates. And if those corrosion rates were to go up, we would take the appropriate action to lower those corrosion rates. Same with biology, right? So if there's biology metrics and how many bacteria can be per milliliter, what type of bacteria can be in there present per milliliter. And what we're trying to do is manage that population, right, in the most cost-effective way we can. So those are the kinds of things that we do, and the same for scale control. There's a mass balance approach where we can look at how much calcium and how much magnesium are in the water. We can do a ratio of those two, and then we can tell our clients whether they're forming scale or not forming scale. And so the idea is to have a predictive tool that not only saves water, saves energy, improves the assets, but also allows us, before they open up their equipment, to know that that equipment is going to be clean, right? So that's kind of the no surprises part of this. And while we do that, we start to get involved in a whole bunch of other different things. It's a very broad topic, and what happens is you end up starting to get into metallurgy, and people start to buy heat exchangers, and then the heat exchanger fails, and they ask you questions about, why did this heat exchanger fail? And so then we have to get into that water and understand what there was in the water. Was it a chloride issue? Was it a stress cracking? Did we pick the wrong metallurgy? All of those things go together in terms of how things work, and we just kind of have worked out that way, and it just has kind of, gotten broader and broader as we go, all with the same metrics, but just kind of a farther reach over simple boilers and cooling towers.
Gotcha. And so, it's like you said, it's a pretty broad range
Sure.
of things that you're covering. So how is that different than a lot of the other companies out there that are doing, say, like water analysis or water treatment?
Sure. So typically the way it's broken down now are two things. You're a water treatment company, right? So and then there's a bunch of water treatment companies out there. And if that's your main focus as a company, what you do is you sell chemicals, right? Or you sell things as a package, right? So we're gonna treat all your water for X amount of dollars, right? Or we're gonna sell you this chemistry at some dollars per pound. And if you're going to do that, you then provide some sort of service on site, right? Which is you kind of define. And what we found, and again, obviously I worked in this industry, but what we found there was that there really wasn't any reason to act in the client's best interest, right? That's, a lot of the people do. A lot of people are very good people. I'm not trying to malign that industry, but
Hmm.
if you get paid to sell chemical, right, you're going to try to sell chemistry, right? So you trying to save water or energy for your client doesn't really align with your goals as a company. And if your goal, if how you get paid is how much chemistry you sell, and that's how you put money and food on the table, that's what you're going to do, right? And the same with equipment manufacturers. So there's also people that sell equipment, the same exact thing. I'm going to sell you the equipment that I have, and this equipment's going to do this. Now, they may not be there to support that equipment afterwards, or that support may be different. They may not look at the entire balance between chemistry and equipment when they do these kind of things. So that's one aspect of the industry. And then the other aspect of the industry, or the other part of the industry, are laboratories, right? So there's a lot of laboratories out there, and those laboratories will analyze things for you, right? So you give them water, they're going to tell you what's in the water. But that's really that's really where they end, right? So if your job is to figure out, if you're not a chemist and you're trying to figure out what that water chemistry does, those labs really aren't going to help you, because they analyze water for all kinds of people. They don't know if this is drinking water, cooling tower water, or closed loop analysis. So what we do is we try to, we call it having the biggest toolbox in the world. We try to use everything, right? So we try not to go in with a predisposed idea of this is how you're going to solve this problem. We try to gather the data, look at what's going on, and say, okay, listen, here's the chemistry of what's going on. So we can solve it in 4 different ways, right? There's a mechanical solution, a chemical solution, there's a mechanical and chemical solution, and there might be another solution we haven't even thought about, right? We
Hmm.
then put those solutions together from a cost basis, and then present those to the client and say, hey, here are the 4 ways you can do this, right? So now let's look and see how these match up with your goals, right? If your goal is to save a bunch of water and you have a piece of equipment already on site, we can use that. We can redirect things over here. That may be a great way to do it. Or maybe it's investing and figuring out what the ROI is on a piece of equipment to save water. Or maybe it's a, hey, we need a chemistry approach because we're failing today. And then we'll think about we'll think about a mechanical approach, in a year and a half once we've gotten through this issue. So we don't, we try really hard not to force a solution because that's the only way to do it. We try to have a strategy as we go forward, right? And we try to make sure that that strategy will last, if that
Yeah.
makes sense.
Oh yeah, definitely. I mean, it's like you said, you're aligning what you're doing with the customer's interests for sure. And you're
Right.
not associated with any one specific technology or the other, right?
Correct.
You're independent.
Right. And we will not take money so we don't take any money from anybody. There are absolutely technologies that we like, and we've talked about this,
Sure.
that there are technologies that we have vetted, right? And once we vet a technology, it kind of goes into our good technology. We trust this technology. Doesn't mean it's right everywhere. Absolutely not. But it is a technology that we understand, we can apply that, and we can use that when necessary. And then there's technologies that are kind of in that gray area where maybe it works, maybe it doesn't. We don't have enough information yet, so we'll consider that, but really, not in a really rational way yet. We're trying to figure out what's going on. And then there's technologies that we've tried and we know that they don't work, and so we put those in another bin, trash bin, and we don't use those anymore. But
Right.
those are the kind of things that we're trying to do so that we have a huge portfolio of ways to solve a problem.
No, I think it's a great approach, like I said, to align yourself with, the customers or the end client's goals
Right.
is great. And it, like you said, incentivizes you to be doing what's right for them
Right.
as well. So,
Right.
we're pretty focused. I know a lot of the work that you do is like in some of the food processing or food service.
Mhm.
We're a little more focused into the commercial market.
Yeah.
So high-rise commercial office buildings, hospitals, hotels.
Yep.
We have some district plants here in the Houston area. So I'd just like to talk a little bit about some of the applications that you've worked in some of the commercial buildings.
Right. So we've worked in a bunch of commercial buildings, right? So commercial buildings typically have, 3 to 5 areas where we might overlap with that commercial building. So most of them have a chilled loop in them, right? So they have some
Mhm.
sort of loop that's what they would consider closed. Um, Depending on where you are in the country, they also can have a hot loop, right? Houston may not have hot loops, but other areas do.
We do. They're just not used that much. Maybe more for humidity control than anything else.
Exactly. Um, then, depending on whether they're hooked up to a district energy site, they may or may not have their own cooling tower system,
Mhm.
right? So you've got those 3 things, which are typically the main things. Then after that, you've got the potable water system, right? And so we've done a lot more work in the potable water systems recently, and that's with just managing the quality of drinking water and typically understanding how that water runs through the building. But what I'm really saying is that as we have been driven towards reducing water consumption overall, we have all these water saving features that are coming in, right? So we have eyes on our faucets, we have low flush toilets, all of which are great. The problem with them is that the way the water system was designed originally didn't really account for that reduction in water usage. Therefore, what happens is the life of that water, or the amount of time that water resides in the building, has gone way up.
Sure.
As that life goes up, or as that residence time in the building goes up, the disinfectant that's there goes down. So you've kind of got these 2 things working against each other. And what we've spent a lot of time working on over the past couple of years are technologies and how we can address that without, wasting water. Because if the solution to that problem is flush, I've really kind of wasted my money on low flush toilets and eyes and on the faucets. It just doesn't make any
Mhm.
sense to me, right? And really, that was the only solutions that we've really had. We've looked at, and these are there are lots of technologies out there. We've looked at ways to add disinfectant. There's ways to do that. We still run into issues with that disinfectant doesn't go unless the water goes there. So you're still stuck with flushing to get it there. So you've added a complexity to that building as well as not really solve the problem, right? And that's kind of where we've gotten, where we have started to recommend and use the triple clear technology, right? So we've talked a little bit about that
Hmm.
as a technology that has helped us solve this problem, right? So the triple clear technology, we've kind of vetted that in terms of that it functions, it removes bacteria, it removes viruses, it allows us to put it in the beginning of the building as well as at the end use points, and allows us to make sure that after that point, we know that the water is, substantially bacteria free, right? Or at least a 6 log reduction in bacteria, which is what we care about, right?
Sure.
And that's becoming more important now, even with the COVID-19, is because, when you restart your building, you need to replace all your filters. You can't let them sit, right? Now, one of the advantages that we're seeing from this particular technology is that you don't have to replace this technology. And that's because it has a built-in biocide within it with the silver ions, right? And it maintains its electrostatic charge, right? So from my client standpoint, when I'm trying to protect their spend, if I have to go and tell them, because this is going to happen again, this whole pandemic thing, this is not the last pandemic we will probably go through, unless, I hope it's not, but probably not. If you have to, go through this again, replace, a building can have 50, 60, 100 filters in its drinking fountains. If you have to replace all those, that's expensive, right? So if I
Sure.
cannot replace those and I don't replace them until I need to, that's a cost savings for my client, as well as making sure that that water is bacterial free, right? So those are the kind of things that we're looking at from a commercial standpoint, or commercial building standpoint, in terms of what's going on, as well as as well as fountains, right? So we look at fountains, decorative fountains in those systems, making sure that those comply with ASHRAE 188, as well as, the potable water, hot water systems, are all things that we end up looking at and touching in some way or another in terms of the chemistry that's going on in that system.
Yeah, we've seen decreased occupancy here in Houston, and we've had less of a shutdown than some of the other cities, but still lower occupancies. And we've done flow audits on domestic water and see on even a fully occupied building an average of 1 to 2 gallons per minute per floor. I mean, it's just not a lot of
Right.
water moving through these buildings. So even lower occupancies, like you mentioned, maybe another pandemic or just an extended period of lower occupancy where people are working from home,
Who
can
knows?
definitely
Right.
see
We
the
don't
that an
know.
issue. Yeah.
Exactly. We have no idea when this is going to happen, and so one of the things that we try to give our clients is a guideline, right? So you can say things like, "Well, all right, I have some people in the building, so it's not unoccupied, right?" Well, yes, but you still have higher residence time of your water. So how do you know what's going on? Well, the only way to know is to test, and it doesn't have to be an expensive test, but if you just buy, and again, you can go to the pool store and buy a chlorine tester. We recommended the ones from Hawk, but you can go and get a little strip and go around and test the drinking fountains, right, or the sinks. If you have a chlorine residual, you're fine, right? You know that water's residence time is good. If that isn't good, right? If you're getting zeros on chlorine, you have to flush. Well, how long do you flush? You flush until you get chlorine, right? That's the metric, right? Which sounds obvious, but if you don't let people know how long to flush, then it's going to be subjective and open to interpretation, right? And as we've seen through this pandemic, the more subjective and open to interpretation things are, the worse it gets, right? So we really want to be very directive. Here's the guideline: flush until you get a half a part per million of free chlorine, because at that point you know that you've got fresh water in the system and that water is substantially bacterial free, right? So that's the important thing for us in terms of that. And then in terms of just, you know, planning, right? Making sure you understand what you need to do, right? Because what's going to happen is we're all busy. We're all, we're either not paying attention because, we're not engaged at work, or we're super engaged at work and we're really not planning. So somebody's going to come to you in a week and say, okay, time to open the building. And you're going to go, what? And so having a plan, right? So knowing that I need to have all the filters in stock, right? To replace every single filter, right? That right there is difficult, right? But if you haven't thought about it and they tell you to open up a building in a week, you're not going to be able to get those filters. So get your filters in stock, right? Make sure you've got a plan in place for, if you've got a water softener feed in the kitchen, it needs to be regenerated, right? You can't let that thing sit, right? All of these little pieces of the puzzle have to be thought out. And that's what, that's part of what we're trying to do right now. We're spending a lot of time is having meetings saying, okay, listen, where are all the filters in this system, right? Where are all the water softeners? Where are all the sinks? All your sinks have eyes on them. Do you know how to disable those eyes so that you can flush, right? You don't want to wake up that morning to flush and realize you have no idea how to disable that eye so that it will flush, all the time. Maybe they do, maybe they don't, but having that plan in place and then a way to document how you are flushing and that you're getting a residual is critical to how you are going to open up that building safely. Because if you don't, then you're just going to have more issues down the line, right? And that goes beyond potable water as well. So if you've got a water reclaim system, right? And that water reclaim system it's just been sitting there, right? You may need to disinfect that water reclaim system, right? You need to check those ultraviolet lights on there, right? You need to make sure that those things have been serviced. You need to make sure that you've, changed out your ultraviolet light bulbs, your UV bulbs the last year. You've changed your sleeves, right?
Mm-hmm.
Those quartz sleeves, because those are things that people generally don't do. And then decide, have I done enough? This is the time to clean things, right? So if you're not cleaning things right now, it's time to do it. Making sure that on your hot water system, right? So your hot water system hasn't run. So what are you supposed to do? Well, you have to flush it. You have to flush everywhere, and you have to flush until you get the temperature you're supposed to get. So if you deliver at 120 degrees Fahrenheit, you need to check 120, so that you make sure you get that water there. And that's a challenge. And if you haven't thought through how much time that's going to take, so you pick a 50-story building, that's going to take you 3 to 5 days of work,
Sure.
a couple of guys. And if you haven't planned that out yet, this is the time to start planning it out and understanding what you're going to do. Because otherwise you're going to get to a place where you're going to do this poorly, and the consequences are you're going to have water that's potentially hazardous. And that's what we're trying to prevent. That's what the CDC recommends, right? So if you go to the CDC website, they have a link there. They kind of give you a general outline of what to do, right? And then part of what I've sent you is just a checklist, right? Because taking that and having a checklist as you go through this is the best way to do it. So you've got a checklist, and then thinking about things like cooling towers. So if my loads are way down, and I've got 4 cells up there on my roof of my office building, and I'm only using 1 cell, right? And 3 of them are sitting stagnant, I should be on a daily basis, right? Or every other day, changing which cell is circulating so that I make sure that I don't get stagnant water up there. So those are all things that people should be thinking through. Same with swimming pools, right? So again, you have a swimming pool. Is it being used right now? Depends where you live. A lot of places, no. So are you maintaining it? Are you not maintaining it? So those are all things that should be looked at as you go. And if you have, for example, let's say, and again, I don't know if you guys work in the hospitality industry or not,
Mm-hmm.
but if you have a hotel room, right? So now think about the people that have hotels, right? I have 150 rooms. I need to flush every room, right?
Yep.
And that's something that needs to be done and documented. And so what we are seeing people do, or what we're advising people to do, is we're working with people. So a lot of them still have cleaning staff that are on site. And to help stay ahead of this is that let's use that cleaning staff to go through, document what they're doing, so that when it does come time to open up, you can just walk in there, do a quick test, say, yeah, the free chlorine's in range, I'm good to go. Or say, no, I've got to do a little more flushing and get that free chlorine up there. But you'll at least have started that process down the road versus not having a process.
Yeah, and those are great guidelines that you put together, and we appreciate you sharing those
Mm-hmm.
with us, and we'll definitely make those available, for people to download, and I
Mm-hmm.
believe it has all your contact information on there as
Sure.
well. So,
Yeah.
and I just want to go back to a little bit on what it is that we're trying to prevent, or what the potential is. You said that the potentially hazardous water, and I mean, we're not talking about COVID-19. It's not a waterborne virus,
Correct,
right?
So
it's
correct, right.
and but the there have been some headlines of buildings where there's, like, say it's a old folks home or a retirement home, and it's
Sure.
They've had patients that had COVID there, and they've moved out, and then they have lower occupancy and then get Legionella in the building, and then that can lead to other issues. So can you talk just a little bit about the bacteria side of that, or what we're trying to prevent?
Right. So we have some of the safest water in the world in the United States. It's fantastically safe. However, even though it's very, very safe, that doesn't mean that it's bacterial free, right? And people sometimes get confused about that because we talk about bacteria in terms of how many bacteria there are per milliliter of water, which is a very small unit. So I may get no bacteria in 1 milliliter of water, but if I were to expand that out to 1,000 milliliters, I might find 2 bacteria per 1,000. That's fine. That's still totally acceptable. It's not going to hurt you to drink that. That'll be fine. However, when those 2 bacteria get into your building and then they sit around and they don't have any chlorine because the chlorine has dissipated, then they start to multiply, right? That's what bacteria do. So those 2 bacteria can, very quickly, logarithmically grow to very large numbers. And if they happen to be Legionella and there happens to be, a place for them to grow, Legionella bacteria can also do the exact same thing. So what we're trying to do is prevent that disinfectant from going away because that's what maintains the control of the bacteria. So as that water sits there, the bacteria grow, right? And then the first guy or woman that turns on that shower, right, or that drinking fountain, or that other area that aerosolization source, right, shower, whatever, tends to then inhale that bacteria, right? And when that bacteria is inhaled, those water droplets go into your lungs. That's when you potentially can catch Legionnaire's disease, right? So that's really what we're trying to prevent in terms of how things are going. And you're absolutely right. In fact, old folks' homes, extended care facilities, those are places where you have a population that's susceptible to Legionnaire's
Sure.
disease to begin with. And if that water's not moving, you can have some real issues with those kind of things. And so what we're trying to prevent, really the whole CDC guideline right now is to prevent a Legionnaire's outbreak on top of a COVID-19 outbreak when we all go back. And that's really what we're trying to do is that, if you think historically, we've never had a situation like this before in our lifetimes, right? Where everybody has stayed home for 6, 7, 8, 9, could be 3 months before we all go back. And even then it may not be, as we used to. So this is not going to go away tomorrow, right? This is going to be something that you may have to flush for, 6 months, on a routine basis. And you may have to manage your population in your system, right? So we work with some large buildings in downtown Chicago. Well, they have, 55 floors. About 4 of those floors are occupied right now. The rest of the people are staying home. So they need to know, and then some of the floors switch. Sometimes they'll bring a company who will say, well, we're going to be here for a week, right? So they need to know about that, right? They need to communicate, understand where they're at, and then come down and say, we're going to flush before you get here, right? To make sure things are good. And make sure all those things are where they're supposed to be. And then you have to make sure that as you do that communication, right, that you're also documenting what you're doing. Because ultimately, this is a liability situation,
Sure.
right? Because the difference between COVID-19, right, where COVID-19 is something that you have to really catch from, human to human transmission, Legionnaire's disease has never been shown to have a human to human transmission. It's an environmentally acquired disease. And if you're going to acquire something from an environment, ergo, that means you did something wrong, Mr. Building Owner, right? Or Ms. Building Owner, because you didn't control the environment correctly. And so, the potable water supply is deemed safe, and therefore something happened in your building, and therefore I'm going to sue you, right? And nobody wants that. And again, it's also just part of, being a human being and not wanting people to get sick. Because
Sure.
there's nothing good about that either, right? I mean, it's about, your brand and everything else, right? You don't want to be that, hospitality company that had the Legionella outbreak, right? We've had those in Chicago. In fact, we've had them all over the place. And it really puts a poor name on your brand.
Yeah. So you mentioned kind of the process of or the priorities being some of the point of use filters, things like that. So, and I know that you have in the guidelines some pretty in-depth, but even like the flushing routine that you talked about, it's pretty well spelled out in there. So just some like, if it were kind of the high points of places to concentrate for when they're opening their building back up, kind of the point of use filtration, hot water systems, and then I guess the cooling tower loops are going to be the big areas potential for that Legionella bacteria. or other
Right. And
material.
so exactly. And so, it's definitely making sure you know where all your filters are and you get those replaced. Um, flushing your shower systems, right? Those are really important. And the cooling towers are interesting because, these buildings still have maintenance staff and they're still doing some cooling. So that's something they need to be doing today, is making sure that they're managing that system so it doesn't remain stagnant, because it'll turn on its own, right? So if you're going to keep it turns out apparently in Houston it's humid, right? And yucky.
Just a little
And so
bit.
just a little bit, right? And it's probably humid now already, right? Or at least, well, it's getting there. So you don't want your buildings to get moldy. So you're going to run some cooling to keep that there. So you want to make sure that that cooling tower today, even though it's not working as hard, is not getting stagnant, and that there's a biocide residual on a regular basis in there, so that when it does go back to being all systems go, it's ready to rock and roll, and you don't have any issue with biocide at that point, or Legionella growth.
Yeah. So, what would you say, if we're looking a little further out,
Mhm.
like 6 months, a year, 5 years out, how do you think that the COVID-19, the pandemic, everything that's been going on is going to change building designs or water quality control going forward?
Well, there's a couple things that I hope happen. One of the things that would really make a lot of this a lot simpler is if we had recirculating domestic water systems, right? So right now, the way our domestic water systems work is they go into the building and then they don't move until somebody calls for water, right? And so because of that, there's no way to monitor what's going on, right? You could put a monitor on there, but it's not going to help you. So if you have a recirculating system, right, that you can monitor a disinfectant level, and in fact, you could bump that disinfectant level very easily and have it
Hmm.
circulate. And that way you cut down on the amount of area that you have to waste and treat, right? To get a disinfectant level come up. So, longer term, and that's a difficult retrofit for a building, right? They just aren't designed for that.
Sure.
But for new buildings, that would be what I would recommend people look at, right? And we're starting to see those recirculating systems, crop up in terms of discussion. So that's an important thing, and not that difficult to do. And you don't have to recirculate every square foot of it, but if you recirculate the mains, and you just have the takeoffs that you have, that would really
Hmm.
cut down on issues in terms of this.
So you
Um,
would essentially design your cold water like you would a hot water with a return loop. You'd
exactly.
have
That
some
would be
balancing valves and
bingo.
branch, coming back, which are so I'm just curious, how would the 90.1 ASHRAE 90.1 standard, it's kind of a little bit of a gray area on the hot water side where you have the pump running continuously.
Yeah.
You'd have something similar on the
Yep.
domestic side, and I guess it's a trade-off of the energy versus
It really
having
is.
clean water. So
Exactly, right? And so where would you do this, right? So this would be more important in areas where you're going to have people that have susceptibility, right? So if I'm in again an extended care facility,
mhm.
a hospital, places like that, those are where I would really focus on it, because I think you can argue that the safety at that point is much more important at that point
Sure.
than the minimal energy usage, right? Um, Big, huge office buildings, again, it depends on how much water is being stored and what your population is. If you have a whole lot of showers, things like that, those are things that you would definitely want to, make sure that you have a recirculating system, right? So that's one way to do it, but it's not the only way to solve it, right? So the other way is to improve that filtration that's going into the building, right? So if we don't let that material into the building, then we have, we're much, or at least we reduce the amount, we have a much better shot at keeping the disinfectant going, as well as when that disinfectant does go away, making sure that we can protect the system all the way through. So for those kind of systems, right, an alternative method would be to put a point of entry filter in that doesn't remove the disinfectant, but really is, focused on bacterial removal, right? As
Right.
well as a point of use filters, right? So that you get it from both ends, right? So if you're going to have a drinking fountain, or put it on a hot water system, right? So that again, you have it on that return, you have it on that supply, so that you're able to manage that bacterial population within there. So those are two things that I think are going to become um, a lot more prevalent as we go forward. because we're just going to have less use in these buildings, at
Yeah.
least for the short term.
Yeah. I can definitely see that. And, we had an incident here in Houston about, it feels like 6 years ago, but I think it was only about 6 months ago,
Sure.
where there was a main city line that broke. It's an
Hmm.
8-foot line that served, I think, half the city.
Oh yeah.
And, so everybody was under a boil notice, and it was
Yep.
a real challenge for the buildings that had those boil notices and the flushing and everything that we're talking about now. They had to do, right away, because
Right.
it was a temporary situation. And again, it's not that the
Sure.
city water supply was bad, but at that point it was open and
You don't know, right?
contaminated with anything, right? So I
Correct.
think it's just a little bit more that point of entry filtration solution, especially for maybe the healthcare and even commercial office. I mean, they still have similar liabilities with their tenants, so it's a little more top of mind
Correct.
now, I think, at least in our
Agreed.
market.
Yeah, no, I agree completely. I think those two things will be big, and just improving the overall monitoring of the systems, right? We tend to, um, I guess I use the word believe, right? So we believe the water coming in is good, so I'm going to believe it's good
Hmm.
all the way through. And so, again, things that can test quickly, right? We've talked about the Legionella test that you can do in 45 minutes, right? That's a way for you to have some confidence that what you've done really works out well. And so those are things that I think are going to become more prevalent. There are some other technologies that are starting to come up in terms of material that is, more online monitoring for some heavy metals, things like that, just to make sure that that water supply is safe all the way through. So I think all of that is going to continue.
Yeah, and I mean, it's going to have effects not just on the potable water systems. I mean, having cleaner water coming in and that's feeding your mechanical systems
Sure.
will lead to better performance as well, right?
Absolutely. Right. So yeah, anything you can do to decrease the bacterial loading that goes into the cooling tower is going to help you out, right? All of those things are really good for it. And then, we've talked a little bit about this, but reverse osmosis technology is changing. So things where we wouldn't have considered putting an RO in to feed a cooling tower. Those technologies are now at a point where it's economical to do so. I mean, we're in the
Hmm.
process of, in Chicago, putting a 400 GPM RO on top of an office building to serve a large cooling tower system. And the payback on that system is about 3.5 years, which is fantastic, right? So
Hmm.
those are things that we're starting to see, just kind of a renaissance in the technology of what's going on, and that I think will ultimately continue to be driven just by making sure that water is safer and make sure that we know that we can go into a building, drink the water, walk by the building, not get infected from the cooling tower. All of those things are important, and they'll continue to work.
Yeah, and I think the ultimate consumers of the water, the tenants or the patients, are also going to be more aware of what is in that water, or want to know how the water's been filtered or treated. The more that we're
Sure.
carrying around our hydro flasks and refilling at the filling stations rather than carrying around bottled water. So I think it's gonna
Hmm.
people are just gonna be more aware in general. So
Yeah.
the
No, I,
more
I
we can
agree
do
completely.
to give them that peace of mind is going to be a good thing.
Yeah, no, I agree completely. And I said, we've talked a little bit about it before, but the on-site generation piece is something that we didn't anticipate would have that there'd be benefits. So we've got again, O'Hare Airport. They have an on-site generator where they generate a chlorine peroxide solution called a mixed
Hmm.
oxidant solution. Well, during this COVID epidemic or pandemic, they they were unable to get bleach to do hard surface sanitization, right? So they were able to take the disinfectant from this mixed oxidant system and apply it over on hard surfaces in other areas. And so
Hmm.
there's a supply chain aspect of this that really I didn't think about until we really had started to get into this. And that's something that we have a lot of clients that are they're starting to think not just how am I going to reopen up, but how am I going to prevent things from happening again? What were my pinch points when I went through this pandemic, right? Okay, we all figured out how to use Zoom, and we all figured out that we could, right? That okay, I didn't
Yep.
have to go to work today, right? I could have the same interactions and meetings from home. Okay, what else can we do, right? How am I going to not have supply chain issues? And so those are kind of things where you can bring things in-house to do, then you have one less, chink in your armor.
Hmm. That's really interesting. It's just not something you think about normally.
Yeah. Yeah, you
Um,
don't
yeah,
until it happens. And then all of a sudden again, and, fun isn't the word I would ever use to describe what we're going through, but part of the, part of where I see successful people and people that are going to make it through this is, how am I going to meet this challenge? What do I have available
sure.
today? How do I do it? And if you can meet that challenge and you can figure out some interesting ways, you will be fine long term. And those are things that are important for people to understand, not just from a water standpoint, but just from a life standpoint.
Yeah, I think it is important to kind of keep positive during times
Hmm.
like this, and look for those kind of silver linings going forward. I've had a few other conversations on the podcast and on a similar theme, and I think everybody's hoping that while this is tragic, and obviously we feel for all
Hmm.
of the families that
Absolutely.
have lost, but hopefully we're able to come out of this a little bit better and you know be better as a society because of it, or
Yeah, we have
maybe
to. I mean,
maybe in
that
spite of
really,
it.
right. You're absolutely right. In spite or despite, you have to become better society because of
Sure.
this. And that's critical for everything here. And what, our contribution, our tiny little contribution is making sure that the buildings are safe when they open, right? I mean, that's why, we made the list. We want everybody to have the list of what to do, right? I don't care. Call me if you have a question. This is not something that we're looking to charge people for, right? This is, how do you open up a building, and I hope people take it and improve upon it, right? Because I'm not saying it's the end all be all list and it's not going to fit
Yeah.
everything, but let's work together to make sure that everybody reopens a building and we don't have another, we don't have a Legionnaires outbreak someplace. Then we'll have been successful.
Yeah. So I want to ask you one quick question
Absolutely.
on the water fountains
Hmm.
slash filling stations, and then we'll pick back up on the advice. So
Hmm.
specific on the fill stations, the more, like I said, the more people are using these hydro flasks and not carrying around
Hmm.
bottled water. Can you talk about the research that you've done on these and how you found Legionella in them and what the risk is there?
Sure. Right. So one of the things that we do is we manage particularly large campuses. We manage a bunch of large campuses in the Chicago area, and that involves making sure that water that they drink and that they shower with is safe. And so when you pick a very large campus, you start with the most obvious issues and then you move your way down. And so one of the things that we were testing was drinking fountains, and obviously a lot of these drinking fountains today have carbon filters on them, right? And these carbon filters are there to do important things, right? They do take out lead, they do take out arsenic, they do take out things that are not supposed to be in the water. However, they also take out chlorine, and they do that for taste, primarily because people don't enjoy the flavor of it. The problem is that that allows bacteria to grow, not only on the carbon filter itself, but post carbon. And so we made an assumption, right? And when you make assumptions, right, you often make mistakes. I didn't use the other one, but you make mistakes. And so our initial assumption was that, well, the carbon filter must also really protect you against bacteria. So because the metric we used was chlorine, right? So we would go to the ones that didn't have carbon filters because it's a huge campus, and we would find chlorine sometimes and not chlorine sometimes. When we didn't find chlorine in the ones without carbon filters, we would often find Legionella, right? And that's not an unheard of thing, right? Chlorine goes away. And then what we did accidentally, right, which is how great things happen, is we accidentally started testing these ones with carbon filters, and we found Legionella in them as well. And that was something that was a bit eye-opening to us because we didn't expect to find Legionella in these systems because our assumption was that somebody had tested this. So we went back to the manufacturer, and the manufacturer said, no, we haven't tested it. We just assumed that the cold water, you hear the assume word a lot now, right? We assumed that the cold water would really, prohibit the growth. And what we found is that that's not true. So of about 50 carbon filter systems that we tested, of that 50, about 18 of them had positive Legionella, right? Which is a pretty high number, much higher than we expected. And so that's kind of where we started this search for what are we going to do? because what would happen is we would, the fallback position immediately was change the carbon filter.
Hmm.
Sure enough, you would change it, and 2 weeks later, it would be fine. 4 weeks later, you'd have Legionella back in the system again.
Wow.
So your alternative at that point is you really just have a couple of alternatives then at this point. One was to not put the carbon filter back in at all, right? Just run it without a filter. The problem with that is then the taste issue becomes to the forefront, or it comes to the forefront, and people don't want to drink the water. And then you're back to, I don't have any water moving in the system. So you need to move the water and have people use it, but you don't want to waste the water by having people, flush, flush, flush. And one of the problems with drinking fountains is flushing them is very time consuming, right? So you have to have somebody come in, they either have to take it apart and flush it down a drain, or you've got to put a piece of tape on there and then hope somebody doesn't get it. And you've got to put a sign on there. So it's really painful, and it took a lot of man hours. So we were really, kind of stressing out the plumbing crew at this large university because we were asking them to flush so much. So that's when, as we were looking around for possible solutions, that's when the filter technology that's able to remove Legionella, the triple clear stuff, really, was kind of that solution that we needed for this particular problem, right? So now we know that if we put the triple clear filter in there, the bacteria level goes to 0. We do a post, we clean post, right? So we clean first, right? Because in these drinking fountains, typically the water comes in, goes to the filter, and then goes to a reservoir. That reservoir is about a half a gallon or so. So you get nice cold water out. It makes perfect sense, right? It's a decent design for that. The problem is that you need to clean that material out of there, anything that would be in that reservoir. And so that took a little figuring out how to get peroxide or bleach in there and clean it. And then once you figure that portion of it out and you put the filter in, what we found testing wise after that is we haven't had any positive Legionellas or even positive, bacteria levels over our limit. So all the bacteria has been under that 10 CFU per ml. Theoretically, potable water can have up to 250 CFUs per ml and still be considered potable. So we've had very low chlorine, very low bacteria levels, and we haven't had any repeat counts. And then as we work through this with our client as the solution, right? They also are concerned about costs, because costs are costs, right? And nobody wants to spend more money than they have to. One of the other positives to this is that the filter itself goes until it basically plugs up, right? Versus a carbon filter, which will continue to flow pretty much forever, right? It's really hard on potable water to stop a carbon filter from flowing. Where the benefit of this filter is when it does plug up, that means that you have now used everything up in that filter. It's now plugged. It doesn't want, it's full of bacteria. It doesn't want to go anymore, right? And so now we know that we're going to get a call that says, hey, my water fountain's not going, so it's time to change that filter, versus changing a filter just to change a filter, right? And so from a cost saving standpoint, we actually found that there was a payback for these of about a year to get that filter in the system, because they were basically changing filters out 4 times a year, and now we can go a year to 2 years without having to change a filter depending on the system.
Yeah, and that's a savings of the cost of the material and the time, right? I mean, it's
Exactly.
time consuming to have these guys go around and change out the filters. So the one of the things that I found really interesting about this when we talked about it last was that we're talking about a drinking fountain, and that the Legionella bacteria has to be aspirated. And so what's the risk at the water fountain?
Right. So the risk is that there's a certain subset, right? There's a certain part of the population that aspirates when they drink, right? So aspirates basically means that in the back of your throat, you are making some bubbles, right? If you're making those bubbles in the back of your throat, they can get through to your trachea and they can get into your lungs. I have no idea who aspirates. You may aspirate. I may aspirate. I have no idea.
Yeah,
but I can't assume. I can't put a sticker on that says, aspirators, please don't drink out of this thing. It doesn't work, right? So you have to do that to make sure that you have to protect everybody.
Sure.
And that kind of gives us that protection.
Yeah, so it's been an interesting application for the triple clear, the force field filter that you described, and so we do have the point of use filters you can put ahead of them, or to serve like a multiple, or the direct screw-in replacements now that fit into the units.
Yeah, and those are really nice. Like I said, part of the solution was it also had to be visually pleasing, right? I can't have a $1 billion building where I have, external filters on every below this, even though they're protecting people, it doesn't help. And then, what we're really recommending, particularly, for these new buildings or retrofits is, to go in and do a point of use or point of entry as well. Because that just protects the other parts of the building, because
Sure.
if you find Legionella in one spot in the building, right, it's in other places as well. It's not like it just goes to the carbon filter and hangs out. There's no attraction there, but you're going to find it in other areas, right? And if you find it in other areas, you continue to have risks.
Yeah. So I mean, and I want to get to your advice here in a second, but
Hmm.
the point of entry is kind of that firewall for the incoming water, then the point of use, and then the testing. Those three kind of combined give you pretty good, at a high
Hmm.
level, a pretty good plan for the water quality,
Right,
at least on the
right.
potable side. So, if you're, specific to, I know you have the in-depth guidelines specifically on reopening the buildings, and
Hmm.
we appreciate you doing that. We're going to share those
Hmm.
with everyone. But whether it's specific to COVID or just in general, what advice would you have for property and facilities managers around their water quality?
Well, I think the most important things are to have a plan, right? And that's just not just COVID, just have a plan for your water system, right? When we react to problems, we generally do a really crappy job of fixing that problem, right? So have a plan, and that plan includes performance metrics, right? So define what the performance is for a system, right? So whether that's, let's say that on your potable water system, you've got a 40-story building, whether that's once a month going to 10 faucets on different floors and testing for chlorine, right? If you find after 4 or 5 months that you always have chlorine, great, okay? You can back it off. But after 4 or 5 months, if you continually find that areas are low in chlorine, address those issues, either with filtration, flushing, something, right? So that you can solve that problem. So those are, having that plan. It's the same for cooling towers, right? Have performance metrics in place, closed loops, right? Make sure your filtration is in place. Having those things in place, having a plan to deal with things is the best way to ultimately not have problems, right? Or at least to know what the heck is going on and be able to plan for things. And so typically when we get involved with a building, it's because there's a big issue, right? And so then we all get to sit down and say, if only we had done this 6 months ago, a year ago, those kind of things. And so, those aren't fun conversations for us, right? Because it's no fun to look at somebody and say, we told you you should have done this, or, you should have done this kind of thing right here. It's get a plan in place. And if you get that plan in place, you can at least work towards a solution.
Yeah, I think it's great advice. What is it? The
Yeah.
ounce of planning is worth the pound of cure. Is that
It is, and
something along
people
those
forget
lines?
about it, right? And that goes along with not just the water, but all the equipment, right? And that's for pumps, that's for softeners, that's for UV systems, right? All of those things should have a plan associated with them, right? You don't want busy work. I'm not, obviously, as you get better at things, you can extend the life or that you have to go look at something, but get that together and have that in place to save yourself trouble and heartache down the road.
Sure. And like you said, though, this will have an ROI when you're extending the life of that system or improving the heat transfer performance, all of those things. So it's not just the liability of getting rid of the bacteria.
Right, absolutely. Because I mean, and again, ultimately, what you want is if you're a building operator, if you're a property manager, you want your employees doing high value work, right? So high value work is interacting with clients, right, making them happy, not trying to fix something that's broken in the back that should have never been broken, right? So those are, we know those are successful. When we see that happening, we know those are successful property managers.
Yeah. I think that's great advice. Any other thoughts or anything we didn't cover that you want to talk about?
I don't think so. Like I said, it's about having a plan. It's about understanding and knowing what's going on in your water system. And I think if people do that, I think that they will be successful in terms of managing their systems.
Yep. Yeah, I completely agree. Well, Mike, really enjoyed having you on the show today. We covered a
Excellent.
lot
Yes, we did.
of topics today, but always interesting talking with you. And I appreciate you coming on the show.
Fantastic. I look forward to having some more of these. It'll be fun.
Yeah, definitely. And for everyone watching or listening this virtual episode of Building Value, appreciate you being with us, and we look forward to seeing you on the next episode of Building Value.